Okay, we're going to talk about solving trig equations. So, whenever you solve trig equations, you need to remember that on the unit circle, the cosine of theta and the sine of theta. This will be your x value and this will be your y value for any degree or radian that's on the unit circle. Okay, so we're going to be using the unit circle obviously to find these values. So then you need to remember all trig identities, but one of the really important ones is this right here. Sine squared of theta plus cosine squared of theta equals 1. You can move these over. You can move sine squared of theta over and actually make cosine squared of theta equals 1 minus sine squared of theta. Or you can move cosine squared of theta over and make sine squared of theta equals 1 minus cosine squared of theta. Okay, so that stuff you should already know, so let's get into the problems. Okay, so this is a simple one. It's asking us to solve for theta for this equation on this interval. So if you notice, this interval is actually the interval of our unit circle, because this comes back around to 2 pi. So that's why we use the unit circle to find this. So now if we take 4 cosine squared of theta equals 1, and we divide 4 from each side, we get cosine squared of theta equals 1/4. Then to find this, we just have to take the square root of both sides, which gives us the cosine of theta equals plus or minus, you have to remember that plus or minus, 1/2. So then this gives us the cosine of theta, but we're looking for only theta, not the cosine of theta. So theta is going to equal the value of 1/2 for the cosine value. So if we remember cosine of theta and sine of theta, then we can find where cosine equals positive 1/2 and negative 1/2, and that's going to be our values for theta. So if we go on here, so cosine here is a positive 1/2, go on around, here's a negative 1/2, here is another negative 1/2, and then here's a positive 1/2. So our 4 answers are going to be pi over 3, 2 pi over 3, 4 pi over 3, and finally 5 pi over 3. So those are all of our answers for theta for this equation. Okay, so that's not so hard. Let's go to the next one. Okay, so some of these are going to be like quadratics. They're going to ask for you to solve these, and they may be in standard form. They may be in that form, and if you go from there, you have to solve for them, and I like to factor, but this one is already factored for us. So this is very, very simple. So all we have to do is just set tangent of theta minus 1, tangent of theta minus 1 equals 0, and secant of theta minus 1 equals 0. And then this will give us tangent of theta equals 1 and secant of theta equals 1. So then we find on here, remember that the tangent of theta is going to be the sine of theta over the cosine of theta, and then our secant is going to be the reciprocal of the cosine of theta. So we need to find where, so if we find the reciprocal of this, the reciprocal of 1 equals 1, and then any value on the unit circle where sine of theta over cosine of theta equals 1. So let's find our tangents first. So the square root, so anything over itself is going to be 1. So this over this is going to be 1. So that is pi over 4 is our first answer. And then the only other place on the unit circle where it's going to be 1 but positive is going to be this over this, which is 5 pi over 4. So those are going to be our two answers from the tangent side. So then over on this side, we're going to get some more answers. So then anywhere on here where the reciprocal of the cosine equals 1 is going to be our answer, one of our answers. So the only place where the reciprocal of the cosine is 1 is going to be here at 0. So because this is our cosine, and the reciprocal of 1 equals 1. So our answer for our secant is going to be theta equals 0. So those aren't too bad. So let's get into one that's just a little bit harder. Okay, so this one looks a lot more like a quadratic, which is what I was talking about. So to solve this, I find it easier if you take and substitute in x for the sine of theta. If you do this, then it's easier to see it because it's more like a quadratic. So if it's 2x squared minus x minus 1 equals 0, all you have to do is factor this, which comes out to be 2x plus 1 and x minus 1 equals 0. And then before you do anything with this, you need to plug sine of theta back in. So it's going to be 2 sine of theta plus 1 sine of theta minus 1 equals 0. So then you can set both pieces equal to 0 and solve for theta, or solve for sine of theta. And that will give you sine of theta equals -1/2 and sine of theta equals 1. So then to find our maybe more than two, to find our answers, we're going to see where the sine, which if we remember that's going to be our y value, where the sine equals -1/2. So it equals -1/2 right here, 7 pi over 6, and right here at 11 pi over 6. So our two answers for this half are going to be 7 pi over 6 and 11 pi over 6. So those are two of our answers. So then we also have to check and see where sine is 1. So the only place on here where sine is 1 is going to be at pi over 2, because our sine is 1 right there. So theta equals pi over 2. Okay. So again, that's not all that hard. That's just solving a quadratic. But now the next one, you have to really know your identities. Okay, so let's start on this one. So I wrote this one wrong. This is just supposed to be secant of theta. If that's squared, then this doesn't work. So some things you need to know before we do this is tangent of theta equals sine of theta over cosine of theta, and secant of theta equals the reciprocal of the cosine of theta. And then one final one is that sine squared of theta equals 1 minus cosine squared of theta. Okay, so let's go ahead and write this down here. Tangent squared of theta equals 3 over 2 secant of theta. Okay, so now we know since tangent of theta equals sine of theta over cosine of theta, then tangent squared of theta is also going to equal sine squared of theta over cosine squared of theta. And that will equal, so then we also know that the reciprocal of the secant is the reciprocal of the cosine is the secant. So we can write this as 3 over 2 cosine of theta. So now you can see here we have almost all the same functions, except we have a sine in here. So we know that sine squared of theta equals 1 minus the cosine squared of theta. So we can plug that in to make it all cosines. So 1 minus cosine squared of theta over the cosine squared of theta equals 3 over 2 cosine theta. Alright, so now from here on, since we have all the same trig functions, we can just solve for cosine of theta. So to do that, we're going to cross multiply, which will give us 2 cosine of theta minus 2 cosine cubed of theta equals 3 cosine squared of theta. So then we can move everything to one side, which I'm going to move it this way, because that way we will have a positive first term. So 0 equals 2 cosine cubed of theta plus 3 cosine squared of theta minus 2 cosine of theta. Now again, for this one, if we substitute cosine of theta for x, we can see that this is basically 2x cubed plus 3x squared minus 2x. So then, just normal factoring, we are going to factor out the greatest common factor, which is an x, and then we get 2x squared plus 3x minus 2. And then this just factors like a quadratic, so we end up getting x times 2x minus 1 and x plus 2. And then before we go any further, we want to plug cosine of theta back in for x. So we're going to get the cosine of theta times 2 cosine theta minus 1, and then cosine of theta plus 2. Okay, so then from here we can set all of these pieces individually equal to 0. So cosine of theta equals 0, 2 cosine of theta minus 1 equals 0, and cosine of theta plus 2 equals 0. So then this is going to give us, well, cosine of theta equals 0. This is going to give us cosine of theta equals 1/2, and then this is going to give us cosine of theta equals -2. Now before you go finding all these terms on the unit circle, first we need to check and make sure that all of these are okay to go back in. So if we look, we have our cosines on the bottom for both. So you can never have a 0 on the bottom of a fraction. So our cosine of theta cannot equal 0. So that won't be an answer. So then going back to these, the cosine of theta 1/2, you can have 1/2 on the bottom because it's a actual number, it's an integer. And then for -2, you can have -2 on the bottom, but cosine of -2 is not a point on the unit circle, so you're not going to have that because it's going to be outside of this domain. Okay, so if we find where cosine of theta equals 1/2, we know that's going to be our x values. So we're going to go around, equals 1/2 right here, and equals 1/2 right here. So theta is going to equal pi over 3 and 5 pi over 3. And those are our answers. And then you can plug those back in, and those will make this statement true. So that is how you solve trig equations.